Okay, so today's opener, as I said, it's just a kind of pretty much an overall review of what we've done so far this unit for Unit 6. The first one says, find the solution to the system by graphing. In order to graph, what form does each equation need to be in? Yeah, slope-intercept form. So when we have 2x minus y equals 1, that's not going to be slope-intercept form. We're going to have to get that y by itself to get it in slope-intercept form. So I'm going to write 2x minus y equals 1. I'm going to circle the y because that's what I want to get by itself. How do I get the y by itself?
You add.
Nah.
You go minus 2x.
Yeah, I'm going to minus 2x from both sides.
Come on, Emily.
Okay. So then I have negative y equals, now can I combine 1 minus 2x? No, I can't. So I'm just going to go ahead and bring that minus 2x plus 1 down. How do I get rid of the negative off of that y there?
Divided by negative 1.
Divided by negative 1 each side. So it's going to be rewritten as y equals, okay, what's negative 2 divided by negative 1?
2.
It's 2x. Positive 1 divided by negative 1? Negative 1. Okay, so when I go to graph this, what do I graph first?
1.
The negative 1 on my where? Y-axis. So I go down 1. Then my slope is what?
2 over 1.
And then I want 3 points, so I'm going to go up 2 over 1 again. Or I could go from my y-intercept and go down 2 over 1. Either way, it does not matter. I'm going to graph my line, hopefully a nice good line that goes through all of my corner of my grid lines. That's not going to do it. I do have your quizzes graded too.
Emily, can you give me a ruler?
She probably has like germs all over it from her hacking in her hand.
Yeah.
Yeah.
You sound like Wednesday over there.
Stop.
All right, so good. So then we have our next y equals negative 3, our next equation that we want to graph. Y equals negative 3. Where would I graph that negative 3?
On the x-axis.
What?
Y.
Y equals negative 3?
The y-axis.
The y-axis. There we go. And then what's my slope going to be? I don't have one, right? So remember, Hoy-Bucks. So if Hoy, H-O-Y, it's going to be what kind of line?
Horizontal.
Horizontal. Good.
That's negative 2.
Yeah, I thought that looked wrong. Thank you for correcting me. Like, that's a problem. Why would that be a problem?
Because then it changed the whole thing.
Yeah, then there wouldn't be a point of intersection. And why do we need that point of intersection?
To determine our
Solution?
variables.
Yeah, our solution. So our solution is going to be the ordered pair of where those two lines intersect one another. So what's going to be, if it's an ordered pair, we know it's going to be x, then y. So what's my x value?
I thought it was going to be negative 1.
Negative 1. So if we start at my origin, I'm going to have to go over 1, and then what's my y going to be? Negative 3. Good. How do we feel about those? Like you remember them pretty good?
What if it's not quite a square? That's fine.
Yeah, that's okay. I'm not going to be, yeah, no. If it's not perfect 90 degree in each corner, I am not going to take off points. Okay, so the next part says, use the graph of the line given in the coordinate plane to determine the slope and the y-intercept. Then we're going to use them to write the equation of the line in slope-intercept form. So the first thing I'm going to do is find my y-intercept. Where's my y-intercept?
Negative 3.
Okay, so my
Definitely 90 degrees.
y-intercept is negative 3. And then how do I find my slope?
Go up 3
And then what?
over 2.
And how did you know that was my next?
Because it's a positive.
How did you know that that was going to be my next place where I could
Because it's
plot a point?
rise over run.
Okay? You're right. So your slope's going to be what?
Positive.
What's positive what? What's your rise?
3.
over your run?
2.
Okay. But how did you know you could put a point right here? How did you know that?
Because it hit the X.
And it went right in the corner of the horizontal and vertical grid lines, right?
Yeah.
And what's that point called?
Lattice point.
Yeah, good chance, lattice point. So then we have our slope, we have our y-intercept. What's my equation then going to look like?
Y equals 3 over 2x plus, no, minus 3.
Good job. Perfect. And you don't need to box anything in that area.
I got a box.
Flip it over. We have the back side now. Okay. Our back side says, is the point -1, 5, so is that ordered pair a solution to the system? Well, how do I determine if that ordered pair is a solution to a system? What am I going to have to do?
You gotta put the numbers in the X and Y spots.
Yeah, I'm going to substitute for each equation and see if they work. Okay? So I'm going to have negative, and then what do I substitute for my x?
-1,
Plus, and what's my y?
5,
Equals.
6.
Okay, so let's go ahead and simplify. What's -1 times negative, or negative times a negative is a...
positive.
So you can basically look at this as two negatives touch and a positive, or you can think of it as a -1 times a -1. Either way, we're still going to get +1. 1 plus 5?
6.
The 6 equals 6? Yeah. All right, so we know the first one works. Let's try our second one. So now I'm going to use my second equation, 2x plus 3y equals 13. What do I substitute for x?
-1.
So I'm rewriting my equation. What do I substitute for y?
Positive 5.
Okay. Then we need to simplify. So what am I going to do here? Multiply.
3 times 5.
Which is?
15.
And what else do I multiply?
2 and the -1.
Which is?
Equals -2.
Okay, -2 plus 15.
Would be 13 equals 13, and yes.
So yeah. So is this a solution to the system?
Yes.
Yes.
Oh my god, guess what?
What?
Miss Stuffin is back.
I know. Everybody's really excited about that.
So excited.
I'm excited to get to know her.
I can't wait to nap in her class.
Oh, I'm going to tell her that. Okay. Find the solution to the system by graphing. So this is just like the problem on the front, right? So our first equation is already written in slope-intercept form for me. So let's see. What do I graph first?
3.
The 3, and that goes where?
Up 3.
From my origin. And then my slope?
2 over 1.
Down 2. Okay. I'll graph my line. Nice job. I wish there's an easier way to draw lines on this thing. It's about,
There's an easier way to draw lines on this.
Are
You guys have nice-
drawing them, or-
yeah, so I push the line.
Oh, that's nifty.
Yeah, it is neat, but like if you don't get it right on the thing, it's hard to move. Okay, what's wrong with my second equation here?
You have to divide 3 by everything.
Because I need to get what?
Get the y by itself.
That's right. Get the y by itself, so it's in slope-intercept form. So I'm going to divide each side by 3. Okay, so that's going to equal what?
2x, then -2.
Okay, so when I go to plot this, I start at my origin, and which way do I go?
You go down 2,
Okay, then,
up 2 over 1. Same thing.
so looking at this,
Can I draw a line?
you want to draw the line?
Yeah.
Yeah, you can try.
Okay.
Good luck. When you look at this, once you graph your line, what's your answer going to be? Is there going to be a point where the two lines intersect one another?
Then you almost have it.
Just hit the back arrow. There you go. Is there going to be a point where these two lines intersect one another? Oh, that's pretty good. Now draw your arrows on the end. So what's my answer going to be like for this one?
No solution.
No solution, yeah. So you just put, you
I
can
ju-
do
I
no
just put-
solution in box, or you can put the 0 with the line going from the upper right to
I
the
just
bottom
put
left.
I just put all real numbers.
You should put no solution.
No.
Okay, to go back to pencil mode, hit the pens. There you go, and then box it. Good.
There you go.
There we go. Nice job.
So the new solution is